Hello students, good evening all. So welcome to our next session of chapter Permutations and Combinations. So we just started with our permutations and combinations. It's like introduction, we have done it. So this is our second session. So before starting the session of today, we'll just have a quick overview, like recap of what we have discussed in our previous, that is first session of permutations and combinations, as well as we'll just take a look over the concepts that we are going to cover in our today's session of permutations and combinations. So firstly, in our previous session, we have covered this fundamental principle of counting. So far we haven't entered exactly into the concept of permutations and combinations, but we have discussed the quick background which is required to get into the concept of permutations and combinations. So which is nothing but we have started discussing this fundamental principles of counting, where we have discussed two of the principles. One is the multiplication principle and the other is addition principle. So in multiplication principle, it will be m cross n. If we are having two experiments, which is m outcomes for one and n for another, so then the total number of outcomes will be m cross n. Similarly, for addition, it will be m plus n. Right. So that we have seen for the fundamental principles of counting. And apart from this fundamental principles of counting, there is one more topic that will be important, which is nothing but factorial. So for factorial, what is the basic representation of it? So this is the symbol which we'll be using to represent a factorial. Right. So if we can write n, it will be n factorial, 1, it will be 1 factorial, 5, it will be 5 factorial. So we have seen what is the representation of it and the corresponding definition of it. Along with that, we have seen few properties which are related to the factorial notation. Right. So in that property, the most important one we can say is the 0 factorial. So in general, if we multiply anything with 0, in general, it will be equal to 0. Right. So whereas when it comes to the factorial form, 0 factorial will be equal to 1. So that is the important property which we have discussed. And the other is even n factorial can be written as n into n minus 1 factorial, or else n into n minus 1 into n minus 2 factorial. So likewise, we can represent that. So we have done even questions related to these concepts of fundamental principles of counting as well as the factorial notation and the properties related to it. Right. So coming to today's session, so we are going to start with our first topic, that is permutations. Right. So we are going to enter into our main concept, main subject, that is permutations. So we'll be seeing the basic definition related to it. So as I mentioned, in permutations, we'll be having two kinds. One is without repetition. So one is without repetition and the other one is with repetition. So we'll be considering and discussing each of the case here which is related to this permutations with repetition as well as without repetition. Right. So once we discuss the basic definition and the repetition part and all, so the next we are going to discuss here is some important results which are related to the concept of permutations. Right. So how we have seen properties related to the factorial notation and all. In a similar way, there are few important rules, important results, or else we can say some properties related to our permutation, which we are going to take a look here. right? So after the important results, there is a concept, there is a special thing that is nothing but when objects are alike, right? So here if we are having some experiment, and in that there are some m outcomes or n outcomes, something like that. So amongst that m, if there are some objects which are alike, then what will be the situation, what will be the scenario there, how we'll be finding the total number of outcomes or else the number of permutations and so on, right? So that will be a special case which we are considering here, and we'll be discussing that what happens when the objects are alike, right? So there will be a special formula here when we have objects are alike. So that we'll look over when we move ahead with our today's session, right? And after that we'll be, so in the permutations itself there are few more conditions we can say, so which is nothing but permutation under restriction, right? So these are some conditions or some special cases we can keep it on. So there how we can apply our permutation concept so that we could get the result there. So there are few statements here which are nothing but permutation under restriction, right? So today's session is entirely a package of our permutation concept. So it will be entirely dealing with the permutations. So in our previous session, how we had a quick background of it. So in our today's session, it's a complete package where we are starting with the permutations itself, and we'll be going into the concept of permutation step by step, and in between we'll be trying to solve the questions related to the each of the concept which we are dealing, right? The questions level will be starting with a basic level, and by increasing the step by step, the level of the questions will also be increased, right? So let's get started with our today's session, guys. So yeah, so as I mentioned, we'll be starting our session with the permutation. So let's see what is the basic definition of a permutations. So permutations is nothing but it is an arrangement in a definite order of number of objects taken, some are all at a time. So it's nothing but arrangement, right? So if for suppose we are having A, B, C, 3 persons, right? So they have to play a game. For example, there is a chess game where these A, B, C are 3 players which they are playing here. So how many total arrangements we can say? This, which means how many matches or something like that. So if you observe, A will be playing with B, A will be playing with C, and B will be playing with C, right? So if we see the another thing, that is BA, that will be the same thing, right? So how many matches we can see here? AB, AC and BC. Similarly, if we are checking for the order here, it's a definite order of objects, so order will be important. So BA, the reverse will also be considered here. So likewise, how many arrangements we can see here? That is the case here, right? So if we take only A and B 2 players, how they will be playing? A with B and B with A, that means 2 matches, because here the definite order will be different when it comes to the arrangement, that is our permutations, right? So a permutation is nothing but it is a arrangement in a definite order of objects, whether they can be taken some of them or else all at a time. So now the question is, how we'll be finding this? So this is the basic definition. So whenever you can see permutations is nothing but you have to remember the keyword, it's the arrangement, and the order actually matters in a permutation, right? So order is very, very important when we are dealing with the permutations, right? So as I mentioned, in permutations we'll be having 2 sets, that is without repetition and with repetition, right? So first let's see the concept of without repetition. So when all the objects are distinct, because we'll be having a special case when objects are alike, so that will be a different case. So first in our permutation, right? So in the permutations, first what we are discussing, our first will be when objects are alike. when all the objects are distinct. Right, so in this objects are distinct, we'll be having two conditions. One is without repetition and the other will be with repetition. So let's start with the first one, that is without repetition. Right, so here the number of permutations of n different objects taken are at a time. So here we are having n total different objects and here only some of them are taken at a time. That is are only taken at a time. So the total number of permutations here is nothing but equal to, from the total we have only taken R and here we are dealing with permutation, so it will be NPR. So it will the number of arrangements or the number of permutations given here will be equal to NPR and the expansion of this NPR will be equal to n factorial by n minus R factorial. And you guys know how to find this n factorial and n minus factorial, n minus R factorial values. So that's why we have discussed the factorial concept as a background of our permutations in our previous session of permutations and combinations. Right. So this is the formula applicable when we have all the objects are distinct and we are considering without repetition. Right. So the number of permutations of n different objects taken are NPR. So in case, so here we have taken R at a time. So what happens if we have taken all the n at a time? That means from the n different objects, if I have taken R at a time, n at a time, then it will be NPN. So NPN is nothing but n factorial divided by n minus n factorial. N minus n factorial is nothing but 0. So it will be n factorial by 0 factorial. So while discussing the factorial properties, we have already seen 0 factorial is nothing but equal to 1. So n factorial, which means NPN is nothing but directly equal to n factorial. Right, guys? So this is the case here. So for without repetition, when objects are distinct, if we taken some R at a time, then it is given by NPR. If we are taken all the n at a time, then it is given by NPN, which is equal to n factorial. And here in this permutation, as I mentioned, the order of the items plays an important role. As I already mentioned, the order of any item here while dealing with the permutation plays actually an important role here. Right, and the other condition, that is another important point, the number of all permutations of n distinct objects taken all at a time is nothing but n factorial. So just now we have seen from all the n, if we have taken all the n objects, if we have selected, then it will be NPN, that is nothing but n factorial. Just now we have seen how we got NPN equal to n factorial. Right, so the only thing we have to remember in permutation, which is very, very important, is in permutation, arrangement, its arrangement and the order of the item plays an important role in the permutation. So that we have to keep it in mind. That means here if it is AB and BA, so these two are considered as two different, not a single one. So that's what the order of the items plays an important role meant by the permutations here. Right, so let's move on. So let's solve a question before moving into our repetition concept and important results. So here comes a question. So I hope you guys can solve it because it's related to 56 PR, which means when we expand it, it will be coming into our factorial concept. So we have already seen how to deal with this factorial and solve and simplify it. So I hope you guys can do it. So let's take your time and quickly find the answer and let me know. So here they have given. So we have seen our expansion just now. So NPR is nothing but equal to n factorial by n minus R factorial. And you have to apply your properties of factorial also here. So quickly try and simplify this, guys, and let me know the answer. So here they are not asking you to find the unknown value R. So instead of that, they are asking you to find the value of RP2. So first aim is to find the unknown value R, and then you have to substitute in that and find the answer, find the value of RP2. So here it is given 56p r plus 6. So just rewrite that in the form of our n factorial by n minus r factorial. So then you will be having an idea how to simplify it further. So I hope you have expanded in this format. If you could able to expand this, then you can simplify it easily. So let's just do the first step here. So here it is given 56. So let's write this. So 56p r plus 6 is 2. So that can be written as divided by 54p r plus 3, yes or no, which is equal to 30,800 divided by 1. So that is the exact question which they have given here. So let's simplify this. That is 56 factorial divided by 56 minus r minus 6 factorial here. Right. So this is divided by, so that will be here in the reverse. That means here we'll be having 54 factorial and 54 minus r minus 3 factorial will be here, which is equal to 30,800 divided by 1. So now let's simplify this further. So let me erase this part. So here I'm just writing down here. So it will be 56 factorial divided by, so 56 minus this, it will be 50. So 50 minus r factorial here, and in the numerator it will be 51. So 54 minus 3 will be 51. So 51 minus r factorial divided by 54 factorial, which is equal to 30,800 divided by 1. So now what we have to do? So we have to apply our property related to factorial. So 56 factorial can be written as 56 into 55 into 54 factorial. Yes or no? Right. So in the same way, so 50 minus r factorial, let it be here. And in the same format, 51 minus r, this can be written as 51 minus r into, so if we do minus 1, that will be 50 minus r, which means 50 minus r factorial divided by 54 factorial. So now this 54 factorial and this 54 factorial will get cancelled. right? And then again 50 minus r factorial here and 50 minus r factorial here will be cancelled, and we'll be remaining only with 56 into 54 and this 51 minus r. So this complete thing will be equal to 30,800. Anyways, divided by 1, it will be the same thing. Right. So now we'll be having 56 into 55 into 51 minus r will be equal to 30,800. So now we can write this as 51 minus r will be equal to 30,800 divided by 56 into 55. So let's see the calculation. 30,000 into 800 divided by 56 will be 550, and if we divide it by 55 it will be 10. So this will be equal to 10. So now we got our 51 minus r will be equal to 10. So from here r will be equal to, by rewriting the equation, 51 minus 10 will be equal to r. Yes or no? So 51 minus 10 will be equal to 41. So that means the value of r here will be equal to 41. But here sometimes after solving this huge calculation, if we see 41 in the options, we directly go and tick it, put the answer to be 41. But here in the question they didn't mention us to find the r value. Instead they asked here to find the value of rp2. So now we got the value of 41. So let's find the value of rp2. So r here will be equal to 41. So let's just find rp2, that is 41p2, which is equal to 41 factorial by 41 minus 2 factorial, that is equal to 41 factorial by 39 factorial. So again numerator can be rewritten as 41 into 40 into 39 factorial, and in the denominator it's already there 39 factorial. So these both terms will be getting cancelled, and the value for 41p2 will be equal to 41 into 40. So it will be 41640. So the answer, the value of rp2 here will be equal to 1640. So this is how we'll simplify this using the properties of our factorial, which we have learned in our previous session of, that is our first session of combination, permutations and combinations. So let's move ahead to our next question here. So here comes the question. So here it's related to our permutations. So let's read out the question. So 3 men have 4 coats, 5 waistcoats and 6 caps. So in how many ways they can wear them? That means in how many arrangements, in how many permutations we can say, in how many ways. So just think of the question and try to answer it. So here how many ways they can wear them, which means all the three separate thing, that is coat, waistcoat as well as caps. How many ways they can wear them? So try and read the question twice and try to understand what the question is and how to answer it. So you can consider these three as 3 different events, like 3 different experiments. So 4 coats is one experiment, 5 waistcoats is one experiment, and 6 caps is another experiment. So likewise you can consider, but to wear them he required all the 3. So how will be, what will be the arrangements? But here if you observe, there are only 3 men here. So here if we consider this to be our experiment, so here we are having 3 experiments. For the first it will be for 4 coats. So 3 men will be wearing 3 coats. So 4 coats. So how many will be arrangements here? Like what will be the permutations? So there are 4 coats, among which only 3 will be selected by these 3 men. So one man cannot select 2 coats, right? So 3 men will be selecting 3 coats amongst these 4, which means amongst this n number of arrangements, m number of things, we are going to, the men going to select only 3. That means the arrangements here will be 4p3 for coats. Similarly, if we go by waistcoats, again the same things. So here we are having 5 waistcoat, but here as we have only 3 men present here, they will be picking up each of them 1, which means 3 only will be selected. So what exactly the 3, that we can't say. So amongst these 5, only 3 will be taken. Right, so this is for waistcoats. So this is the arrangement for waistcoat. Similarly, for caps, amongst total 6, 3 men will be picking up. So it will be arrangements of these 6 caps will be 6p3. So now here the thing is, the question is, they didn't ask like how many ways 3 men will be wearing a coat, or else they didn't ask you how many ways they'll be wearing a waistcoat. Instead, they have mentioned that in how many ways can they wear them. That means they'll be wearing all these 3 together. Right, which means all these 3 experiments will be performed simultaneously. Which means he'll be wearing coat, waistcoat as well as cap all together. So when we have all the 3 experiments performing simultaneously, what will be the fundamental principle of counting which will be applicable here? Which is nothing but multiplication principle. So if in the question, if they have mentioned in how many ways can they wear waistcoats, then it will be alone 5p3 we can say it. Right, but here because only one of it is actually wearing, so one of the experiment is only happening, then we can just add it and that will be the answer. But here he mentioned how many ways can they wear all of them. So it will be under the multiplication principle. So hence the total number of permutations here, that means the number of ways will be equal to 4p3 first experiment cross second experiment, that is 5p3 cross 6p3. So we have to find the value, that is 4 factorial by 4 minus 3 factorial into 5 factorial by 5 minus 3 factorial into 6 factorial by 6 minus 3 factorial. So 4 factorial here. So 4 minus 3 factorial will be 1. So 5 factorial divided by 5 minus 3 will be 2 factorial into 6 factorial by 3 factorial. So here the value will be 4 factorial into 5 into 4 into 3, and 2 will be getting cancelled with the denominator. Similarly here 6 into 5 into 4, and with 3 the remaining will be getting cancelled here. So let's do the calculation. So 5 into 4 into 3 into 6 into 5 into 4. So that will be 7200 into, again we are having the 4 factorial which is into 4 into 3 into 2. So that will be the final answer here, which is a huge number, that is 4 into 3 into 2 here, which is a huge number, that is 172800. That is 1,72,800 ways. So these are the total number of possible ways that the 3 men can wear the given coat, waistcoat as well as the caps. So these are our total number of ways. So it will be 1,72,800. Right. So here we have applied our permutations as well as our fundamental principle of counting. So let's move on to the next one. So here comes the next question, guys. So just now I have explained you one question related to permutation, how we'll be solving it in detail. So I hope you guys can solve this question and let me know the answer. So read the question carefully, understand the information which is given there, and try and relate to the things which we have learned. Because these permutations and these kind of questions, you will be getting it while you do the practice. So you'll be habituated with it while doing lots of questions. Then it will be easy to answer when you get any question related to permutations. So read the question, guys, and answer it. So let's read the question. So suppose 8 people enter an event in a swim meet. So there are 8 people, so n will be 8. So in how many ways could the gold, silver and bronze prizes be awarded? So here they have given total number of outcomes here, that is n. So total number of objects here, that is n, and you have to find how many ways could the gold, silver and bronze prizes be awarded. So here the n will be, that is total number of people will be 8, and here they are talking about how many ways they could get the gold, silver and the bronze prizes. So how many people in general, if we talk, how many people can get a gold medal? Only one. Similarly a silver medal, one. Similarly a bronze medal for one, which means among these 8 people we are having a possibility that 3 can be awarded with the prizes. That means one can be awarded with gold prize, one can be awarded with the silver prize and the other can be awarded with the bronze prize. Right, which means amongst this total 8 people, only 3 people will be awarded with the prizes. That means amongst 8 people, the arrangements, the number of ways will be 8p3. Only because only 3 people will be awarded with the prizes gold, silver and bronze. That means 8p3 will be the total number of ways how the people will be awarded with the prize. And this 8p3 will be equal to our expansion, that is 8 factorial by 8 minus 3 factorial, that is equal to 8 factorial by 5 factorial. So let's simplify it. So 8 into 7 into 6 into 5 factorial, and in the denominator we again have 5 factorial. So 5 factorial will be getting cancelled, and 7 into 42, 42 into 8, 336. So then in number of ways how the people will could get the gold, silver and bronze prizes is nothing but equal to 336 ways. Right, so now I hope you guys have some idea how to solve questions related to the permutations. So let's move on. So now let's just see some important results here. Right, so let's just see some important results before getting into our next concept or our next questions related to permutation. So the number of permutations of n different things taking r at a time. So just now we have seen, if we are having total n number of different things and we are taking r at a time. So we are taking r at a time, that is given by NPR. If we are taking n at a time, that will be given by NPN. So here we are taking r at a time, so it will be NPR, which is equal to n factorial by n minus r factorial. Right. So the second point is our NPN, that is the number of permutations of n different things taken all at a time. So if we are having some n different things, but here we have taken all at a time, that means all the n different things has been taken here. That means NPN. So what is our NPN expansion? So we have already seen NPN is nothing but equal to n factorial. And here we are having few more results, that is NP0. So NP0 is nothing but directly equal to 1. So let's see how it is equal to 1. So if we are having NP0, that is NP0. So if we expand it, that will be equal to n factorial by n minus 0 factorial. So n factorial by n minus 0 is nothing but n factorial. So n factorial will get cancelled, which will be equal to 1. That means NP0 value will be equal to 1. Similarly, let's see for NP1. So if we are having NP1, so that will be equal to n. So if you want, you can go by formula and check it. That is n factorial by n minus 1 factorial here. Right. So that means here this can be written as n into n minus 1 factorial. And in the denominator, we are having n minus 1 factorial. So these two terms will be getting cancelled and NP1 will be equal to n. Right. So that's why you can get the answers by using our general formula, that is NPR will be equal to n factorial by n minus r factorial. If not, for easy, you can remember to consume the time while doing the questions. You can remember NP0 will be equal to 1 and NP1 is equal to 1. Similarly, NP n minus 1 will be equal to NPN, which is equal to n factorial. Right. So similarly, you can see, you can write the NPR. So NPR can be written as n into n minus 1p r minus 1. Right. So similarly, we can write NPR in another way, that is n into n minus 1 into. So if we are going until n minus 1, here we will be starting with n minus 2. So n minus 2p r minus 2. Similarly, if we are going until n minus 2, then it will be NPR will be equal to n into n minus 1 into n minus 2 into n minus 3p n minus 3. So likewise, we can write until how many n value, how many r, until whatever the r value we required, we can continue and write the NPR in that particular r value. Right. So these are some important results which are related to our permutations concept. So now let's move ahead. So far we have seen our objects when the objects are distinct, our first case. So far what we have discussed in the permutations. So the first case we have seen is when objects are distinct. So when objects are distinct, in that we have already covered without repetition. So for without repetition, what is the formula, guys? NPR. So now we are getting into the next one, that is with repetition. That means when repetition is allowed here. Right. So the formula for this is given by n power r. That means the number of permutations of n different objects taken r at a time. So the concept will be the same thing. If we are having n different things, and amongst the n different things, if r at a time has been taken, and the number of permutations will be equal to n power r if repetition is allowed. If not, if repetition is not allowed, then it will be NPR. So this is for not repetition and this is for repetition allowed. So the total number of arrangements for both the cases are explained here. For repetition allowed, it is n power r, and when repetition is not allowed, it is NPR. Right. So let's do a question related to both repetition as well as repetition not allowed case in general. So here you can see this question. You can relate it because similar type of questions we have discussed in our first session of permutations and combinations. So I hope you guys can answer this. So quickly answer this question, both the cases, and let me know the answer. So similar question, guys, we have solved in the previous session. So just try and recall it and try to solve it. So we can simply solve it without the application of formula also. So that will be the easiest ways to solve it, how we have discussed in our previous session. So here if you observe, how many numbers between 10 and 1000 can be formed by using the digits. So numbers between 10 and 10,000 will be how many digit number? So it will be 2-digit number. So it can be two digit numbers, or it can be 3-digit numbers, because in between 1000, so 4-digit won't be counted. So 3-digit numbers. So let's see how many ways a 2-digit number can be formed here. That means here. So here in between 1, that is 10. So it will be, so here in this tens place we can have 1, we can have 2, 3, 4 as well as 5. So how many chances we are having for tens place? 5 chances. So whereas if we go for ones place, amongst these 5 digits, 1 digit will be already fixed in the tens place. And here according to the first case, no digit is repeated. That means we cannot have a case of 11, we cannot have a case of 22, we cannot have a number 33, 44 as well as 55. Yes or no? So that's why if one number is fixed, that number cannot be placed here. That means here how many digits will be placed? 4 digits. And both the tens place and the hundreds place, both has to be occurred simultaneously. So it will be multiplication principle, which is equal to 5 into 4, 20. Right. So similarly, we can check for the same thing for 3-digit number. So here how many possible cases? 5. So here after 1 is fixed, here it will be 4 cases, 4 possibilities. If 4 is fixed here, here it will be 3 possibilities. So it will be multiplication principle because both tens place, ones place and hundreds place digits have to be occurred simultaneously. So it will be 5 into 4 into 3. So it will be 60. Right. So the total possible ways for the case 1 will be, so it can be 2 digit or 3 digit. So both 2 digit and 3 digit will not be occurred simultaneously. So one of the experiment will be occurred. That means it will be our addition principle. So now it will be 20 plus 60, which is equal to 90 here. So when no digit is repeated, the numbers between 10 and 10,000 will be formed in 90 number of ways. Right. So similarly, let's try and do our second part where the digits can be repeated. So I hope you guys got the idea how to do it when digits are repeated. So quickly try and do it and let me know the answer for this. So same thing, 2-digit numbers. Number of ways to form 2-digit number and number of ways to form 3-digit number and total number of ways. So 2-digit number here guys. So here the only condition differ from the first one will be digits can be repeated, which means we can allow the numbers like 11, 22, 33, 44 and 54 as well as 111, 222, 333. So these numbers will also be allowed here. So now for the tens place 5 chances, again for ones place also 5 chances because the number which is fixed in the 10th place can also be come again in our ones place. So it will be 5 into 5, that is equal to 25. Similarly for 3-digit number, here hundreds place 5 possible ways and tens place 5 possible ways and ones place 5 possible ways. That is 5 into 5 into 5. So 25 into 5, 125. Right, so total number of ways will be 25 plus 125, which is equal to 150. Right, so when digits can be repeated, the total number of ways will be 150 and when no digit is repeated, the total number of ways will be 90. So this is how we'll be answering when we have questions related to these numbers, which is the easiest way to answer without any mistakes. So now so far in the permutations we have discussed when objects are distinct. Right. So now we are entering into the second part of permutations when objects are alike. Right. So let's see what will be the permutations, the number of permutations when we have objects are alike in the given n objects. Right. So the number of permutations of n objects taken all at a time in which P are alike objects of one kind, Q are alike objects of second kind and R are alike objects of a third kind and the rest are all different. Right. So for suppose, let me write something like this. A, P, okay, B, C, D, E, E. So for suppose here I am having, these are my n objects. How many objects I am having here? 1, 2, 3, 4, 5, 6, 7. So here I am having 7 objects where I have taken all the 7 at a time. So I have selected all 7 at a time, which means what will be my permutation? That will be 7p7. That is 7 factorial or not? Right. But here if I observe my objects in detail, A and A. So these two are of one kind. B is separate, C is separate, D is separate and again these two are of one kind. So now when I have these, so how many are there here? These are 2. So I have to divide with 2 factorial. And how many E are here? 2. Again, I have to divide with 2 factorial. So the mistake in general people will do is they'll add 2 plus 2, 4 and then they'll divide with 4 factorial. So that cannot be possible. We have to take them as different only. That means if we are having some n objects amongst which P are of one kind and Q are of one kind and R are of other kind. So there are 3 types here, right? So and the remaining we are having all are different. So then the number of permutations of these n objects when all of the n taken in time, then it will be equal to n factorial divided by this P factorial into Q factorial into R factorial. So whatever of kind repeating and how many times it's repeating. So with that we have to divide. So in this example you might have observed. So let me give you similar type of one more example so that it will be easy to understand. So this is my objects here. So how many objects I am having? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So here my n is equal to 10. I am going to take all the n objects here. So what are my permutations? So it is given by npn, that is 10 factorial. But here if I observe, s is different, t is different, r is different, u is different, whereas I am having v of same kind 3. So how many are there? 1, 2, 3. So I have to divide it by 3 factorial. And w is different, whereas again I am having x repeating. So how many times x is repeating? 2 times. So I have to divide by 2 factorial. So the number of permutations here is given by 10 factorial divided by 3 factorial into 2 factorial. So this will be my total number of permutations here when we have objects are alike. And the same thing here, this is for repetition not allowed. If repetition is allowed, then it will be, so excuse me. So here repetition is not allowed. That's why it is 10p10 by 3 factorial and 2 factorial, which is 10 factorial by 3 factorial into 2 factorial. What happens if repetition is allowed? If repetition is allowed, the numerator will be n power r. That means 10 power 10 and then same thing divided by how many kinds and the types. So only the numerator will be changing when we have repetition and non-repetition here. So when it repetition allowed, n power r will be the numerator, and repetition is not allowed, npr will be the numerator, and denominator whatever kinds are repeating, so that has to be divided in the denominator. Right, so this is our another case, that is when objects are alike. So let's do a questions related to this. So here comes the first question. So if in case in the question, if they haven't mentioned of repetition allowed, you have to go by taking not allowed. So that's the standard case. So let's do it here. So determine the number of permutations of the letter of the word simpleton taken all at a time. So here they haven't mentioned repetition is allowed, so we'll be considering not allowed. So how many elements are there here? 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So number of permutations here will be equal to, so 10, right? So it will be 10p10 divided by any objects are repeating here. So S, okay, not repeating, I here. So I is repeating twice, so it will be divided 2 factorial. So any other is repeating, so remaining all are different kinds. So this will be equal to 10 factorial by 2 factorial, which is equal to 10 into 9 into 8 into 7 into 6 into 5 into 4 into 3 into 2 divided by 2 into 1. So this 2 and this 2 will be getting cancelled, and then it will be the entire multiplication of 10 into 9 into 8 into 7 until 3, which is the whole value will be equal to 181440. So this will be the value here. Right, so now you guys got an idea how we'll be doing when objects are alike. So let's do one more question here. So here comes the next question. I hope you guys can quickly answer this one. So it's easy. So how many 7-letter words can be formed using the letters of the word? That means it's simply the number of arrangements they are talking about here. So number of permutations, or else we can say number of words, we can say that will be equal to. So how many letters we are having? 7-letter words. So it will be, all will be selected. So 7p7 divided by any repetitions. So a is repeating twice. So 2 factorial and ri. So remaining are different. So it will be 7 factorial by 2 factorial, where the answer will be 7 into 6 into 5 into 4 into 3. 2 will be getting cancelled. So 7 into 6 into 5 into 4 into 3. So the value will be 2520. So using those 7 letters, we'll be forming these number of words using the letters. Right, so let's move ahead. So here comes the next question. So I hope you guys can do it and let me know the answer quickly. So find the number of permutations of the letters of the word Allahabad. So you have to first know how many number of letters are there, and then you have to get to apply the formula, the thing which you have discussed, and to get the number of permutations. So let's read out the question, guys, and quickly do it and let me know the answer. So here let's see how many number of objects, that is n will be equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So n will be 10, right? So number of permutations here will be equal to, all will be selected at a time. That will be equal to 10p10. And let's see, any are repeating. So A, and A. So a set of A is repeating 4 times. So divided by 4 factorial. Similarly, L is repeating twice, so into 2 factorial, and then HBD. So these three are three different kinds. So we'll be having 10p, 10 divided by 4 factorial and 2 factorial. sorry, it is 9, right? Sorry, number of elements are 9, sorry. So then it will be 9p9. So it will be 9 factorial divided by 4 factorial into 2 factorial. So let's expand it. So 9 into 5, sorry, 9 into 8 into 7 into 6 into 5 into 4 factorial divided by 4 factorial into 2 into 1. So this 2 will get cancelled and here 2 with 3, and we'll be remaining with 9 into 8 into 7 into 15, 5 into 3. Right. So the answer will be 9 into 8 into 7 into 15, which is equal to 7,560. So here the total number of permutations of the letters of the word Allahabad will be equal to 7,560. So that's all for today. So in our today's session, we have started with our permutations. And in this permutations, what we have discussed with two kinds. That is, one with objects distinct and the other is when objects alike. So in these two cases, again we'll be having repetition. So repetition not allowed. So when repetition not allowed, the formula will be NPR here, whereas repetition allowed, so repetition allowed, then it will be N power R. Similarly, when objects are alike, same thing, repetition not allowed. When repetition is not allowed, it will be, formula will be NPR divided by the kinds. How many kinds are there? Those by divided by those kinds. So it will be P by Q factorial by some T factorial, like that. And similarly, when here repetition is allowed, then it will be the numerator only changing, that is N power R divided by the repeating letters, so Q factorial or T factorial. Right. So this is the thing we have discussed in our today's session of permutations. So we'll just have the restriction, permutation under restriction, those kind of things. So that we are going to discuss in our next session of permutations and combinations. So if you guys have any questions, any doubts in this particular session, you can come and contact me anytime. So you can let me know so that we can have a discussion to clarify your doubts. So that's all for today. We'll continue the rest of our permutations in our next session. Thank you guys.